Hello everyone and welcome back to our videos. Today we will talk about turbine fuel system. In the last two videos we talked about the reciprocating fuel system and the types of fuel used, also the components of the reciprocating fuel system. As that we will talk today about the turbine fuel system and the component of the turbine fuel system, also the types of turbine fuel system. The purpose of a turbine engine fuel system to store, transfer and meter fuel to turbine engine in the proper amount of right pressure. Components of turbine fuel system. They are like the reciprocating engine, but they have some additive. The components of turbine engine are tanks, lines, valves, pump, filters, gauge, fuel control unit and fuel nozzle, and the last one, fuel heater. A cross-feed system allows any engine on a multi-engine aircraft to be fed from any tank. This can be used to maintain a balanced fuel load. Here we have a type of turbine fuel, and here we have the freezing point. The Jet A has freezing point at minus 40 Celsius, and the Jet A1 has the freezing point at minus 47 Celsius. Lower freezing point of Jet A1 makes it useful for aircraft that fly at extremely high altitude for long periods of time. The Jet B has a freezing point at minus 50 Celsius. Jet B is similar to the military Jet P4 fuel, which is the primary fuel used by military forces because of its availability overseas. Here we have the type of turbine fuel. Jet A colorless, the equipment control color. Here we have the pipe banding and marking, and here the refueler decal, and in the all of fuel on turbine system. Jet A, Jet A1 and Jet B are merely numbers that label a particular fuel and do not describe any performance characteristics. Jet fuels are not dyed. There is no color identification for them, as we said in the previous figure. They range from colorless to straw-colored, amber, depending on age or the crude petroleum source. In this video, we will not talk about the tanks of turbine engine and the lines, also the pumps. We will talk about one type of pumps that is different from the pumps on the reciprocating engine. And the lines and fittings, also the tanks, they are the same as we talked on the reciprocating engine. So we will talk about the fuel control and fuel nozzle, also fuel heater, and some additives to the turbine fuel system. engine-driven pumps. The main fuel on all turbine engines is constant displacement pump that is driven by engine as an accessory. Type of engine-driven pump are gear-type pumps with one or two gear elements. Some engine-driven fuel pump also contain a centrifugal boost element that increase the fuel pressure before the fuel reach the primary gear element. To prevent fuel from draining out the system when the engine is shut down and to keep fuel from recirculation within a filled gear element, a check valve is installed in or at the outlet of each gear element. In addition, a pressure relief valve is built into the pump housing to limit pump fuel pressure and provide protection to the fuel system. As we see in this type of driven pumps, here we have the inlet and here we have the boost element or impeller. Here we have the primary gear element and this the secondary gear element. When the drive shaft rotates, the primary and secondary gear will rotate and the fuel will goes to this area. After that, from the check valve, they will go to the outlet. If there is a rising in the pressure, here we have the pressure relief valve as we talked. Fuel transfer ejectors. Fuel transfer ejectors, sometimes called jet pumps. The purpose of the fuel transfer ejectors to facilitate the transfer of fuel from the main tank to a boost pump. Where is the location of the transfer ejectors? The transfer ejectors located at the lowest point in the fuel tank and remain submerged unit, the tank virtually empty. Transfer ejectors have no moving part, consist primarily of tube with construction. Low pressure area forms of the restriction. The low pressure area draws more fuel from the tank into the line. Fuel heater. The purpose of the fuel heater to prevent the entrained water freeze and formation of ice crystals in the fuel supply. The resulting of ice crystals can clog fuel filter or other fuel components, and unfiltered fuel containing sediment and ice crystals flow downstream to other fuel system components, possibly resulting in component malfunction or fuel flow interruption. To prevent this condition, the fuel system incorporates a fuel heater. Typical fuel heater consists of a heat exchanger that utilizes either engine oil or bleed air to warm the fuel. In a typical fuel heater, fuel continuously flows through the heat exchanger while the flow of the engine oil is regulated by a shut-off valve. As we see in this figure, here we have the inlet of the oil and here we have the inlet of the fuel inside these small pipes. that will make a transfer between the fuel and the hot oil, and this will make a heater for the fuel and will make the fuel to continue go to its location. As we see this, we find that on a large transport aircraft like a turbine engine of V2000 2500, that's this element called fakuk, and this fakuk will make a heater for the fuel as we see in this figure.